Okay, so we're going to find f of 1 plus h minus f of 1 and then divide that by h. So first compute f of 1. So that simply means plug in 1 into x right here. So you'll have 2 times 1 squared minus 4 times 1, right? And then this would give us 2 minus 4, which is negative 2. So that's what we're going to substitute for f of 1. Now for f of 1 plus h, we'll do the same thing. We'll substitute 1 plus h into every x in the formula. So you'll get 2 times 1 plus h squared minus 4 times 1 plus h. Okay? All right, now this one right here, you have to expand. So that means you have 2 times 1 plus h times 1 plus h. And here I can distribute the negative 4. So that gives me negative 4 minus 4h. So this right here, let's finish distributing that. So that will be 2 times 1 plus 2h plus h squared, right? When you expand that. So carry out the rest. This is minus 4 minus 4h. And now we can distribute the 2 out to all of these terms. So that leaves us with 2 plus 4h plus 2h squared minus 4 minus 4h. And now we can combine some like terms. So I don't have any h squared terms, so there's no like term for that one. Now, these are like terms, and they actually cancel each other. And then the next like term we have is negative 4 and 2. That would give us negative 2. Okay, so this is what we're going to replace for f of 1 plus h. And now here's how you're going to set up the difference quotient. We want f of 1 plus h minus f of 1 all over h. So f of 1 plus h, that's the second box I have. That's 2h squared minus 2. And then f of 1, that's the first box we computed. So minus negative 2 all over h. Okay, and then simplify this. So this would give us 2h squared minus 2. The double negative makes it a plus 2 all over h. And then here again, combine like terms. These will cancel out. You have 2h squared over h. And here again, h and h can cancel, right? So everything will be just 2h. That will be the final simplification for this.
Okay, yeah, that makes more sense.
Yeah, okay.
I think, yeah, it's just, I have to see it in like different ways.
Mhm.
So that made sense.
Okay, good.
And, oh, this one,
Okay, so for this one, we're going to graph g of x. So g of x is given as a piecewise, right? So it's going to be 2 when x is less than negative 2. So here's our xy plane. And we're going to split this up into 2 separate regions at negative 2. So suppose negative 2 is right here. So I'm going to do some dotted line to show the separation. So now when x is less than negative 2, so that's this portion right here, we're going to have g of x equals 2. So that's just the horizontal line at 2. So suppose this is 2, and this would be open circle because it's strictly less than negative 2. And we draw a horizontal line going this way because we have to be less than negative 2. And then when x is greater than negative 2, so now we're looking at to the right of negative 2, that's this region. We have the second function, the one on the bottom. So g of x is this one. So you plug in negative 2 to find what's the y value at negative 2. So you evaluate g at negative 2. That would be negative 2 squared minus 4. That would give us 4 minus 4, which is 0. Now this point, negative 2 comma 0, is a closed point because it has greater or equal to in the inequality. So I find that point, negative 2, 0. Well, that's our intercept right here. And now we just make the curve. Now, if you're not sure how to curve it, you can plug in another point within that interval. Let's say 0. If I plug in 0 into g of x, I will get g of 0 is equal to 0 squared minus 4, which is negative 4. So you have the 0.0 comma negative 4, which is perhaps down here. And now you should see where the curve is going. It's a parabola going upward, but it's only going to continue this way. Something like that. So that will be the graph for g of x equals x squared minus 4, only on the interval greater than or equal to negative 2. And then the one in the pink, that's the function g of x equals 2 when x is less than negative 2. And that completes our graph.
Okay, that makes sense too.
Make sense? Okay.
Thank you.
You could also make
Um,
table of values if you're not sure. For example, for this one, I didn't make any table of values. You could pick -3, -4, and you'll see it's always y value 2. So it's always going to be
Right.
horizontal line to the left.
Okay.
Okay. So we will use this definition, right? So like you said, this will be 2 to the power of 3 equals the inside, which is x squared minus 8. Now you can ignore the parentheses, wouldn't really need it. The reason I had them first, because I want them to be considered as the input, okay? And now we just solved this, so you, 2 to the third is how much? That'll be 2 times 2 times 2, right?
Yes.
So that will be 8. So you'll have 8 is equal to x squared minus 8. And now this is just a quadratic equation. I'm going to go ahead and add 8 to both sides, or you can move 8 to one side and factor, but I think we can handle this, right?
Yeah, so it'd be 4, because it'd be the square root of 16.
Exactly. So you'll have 16 is equal to x squared, and then you take the square root, but don't forget you get 2 answers, right?
Right,
Plus or
plus or
minus.
minus. Okay.
So x is equal to 4 or -4. Now we have to check our answer because it's a logarithm. So make sure to always check. So when you plug in x equals 4, will this input be positive?
Yes.
Yes, so 4 is okay. Now, what about if you plug in -4? Will it still be positive?
Yes.
Yes,
Or no? Okay.
yes. So you're gonna square it, right? -4
Yes.
squared will be
So it's
positive.
positive. Okay.
Yes. So yeah, this checks. So both of these are answers. But
Okay.
remember, always check your answer if you have logarithms.
Okay.
Okay.
Then I should just